Good afternoon and welcome to the next short video in the Ahargana series. In the last episode, we had seen that the duration of a savana ahoratra is not exactly 24 hours, but it varies around 24 hours. 24 hours is only the average. One of our viewers has pointed out that the example I gave there was of Bangalore city. But if you compare Bangalore city with other cities which are further north in latitude, for example, Boston, there is a huge difference in the variation of sunrise time, the time of sunrise. So what impact does that have on the duration of savana ahoratra? Does it have any impact at all? If so, what impact does that have? So let's look at that point in this tutorial. So here is Bangalore, and this is the graph of the time of sunrise in Bangalore every day in 2024, starting from January to December, and I had shown this in the last episode. So sun rises in winter in Bangalore around this is 6:49 a.m. in the morning, and when you come to summer, sunrise becomes as early as 5:53 a.m. That's the range. And this is the pattern of the change in sunrise time in Bangalore city. But what about Boston? So let me switch to Boston. And you see this sunrise time graph is completely different. Not only is the shape very different, but also you find that in winter in Boston, sun rises at 7:15 a.m., whereas in summer, sun rises at 4:08 a.m. Now in Boston, they use daylight saving time, so they will push this to 5:08. I am showing you the winter time, GMT -5 throughout the year. So there is almost a 3-hour difference between the earliest and the latest sunrise in summer and winter respectively. So the question our viewer asked was, does this have an impact on the duration of savana ahoratra? Or is the duration of savana ahoratra in Bangalore and Boston identical for every day? Or do they change? So today the duration of savana ahoratra in Bangalore, is it the same as the duration of savana ahoratra in Boston today? The answer is no. They do change, and that's what I'm going to show you next. But before I go to that, I will show you here these two graphs side by side so you can see how huge this difference in sunrise time is. And why are we interested in sunrise time? Because sunrise defines the beginning of a savana ahoratra in the Hindu calendar. And that varies so much. So surely this is likely to have an impact on the duration of savana ahoratra. Now let us take a look at the actual ahoratra length and see what happens to it. So this is the graph for Bangalore, ahoratra length at Bangalore. We have seen this in the last episode, and it shows that for every day in 2024 from January to December, the length of a savana ahoratra varies, fluctuates around 24 hours. So it decreases, then it starts increasing, decreases a little bit, again increases, and finally decreases a little bit. But the overall fluctuation is less than a minute. So for example, at the peak here, it is 33.5 seconds greater than 24 hours. And at the trough here, it is 41.5 seconds less than 24 hours. So fluctuates less than a minute is what I had said in the last episode. And the average is 24 hours. This is a computed average, and across the 365 days of 2024, the average is exactly 24 hours. Now what about Boston? That was the question. So if I take Boston, I obtained the data from JPL Horizons. I plotted the data, and you see that indeed this graph looks different. So the duration of savana ahoratra for any given day in Bangalore and Boston are not the same. But the rough pattern still holds good. In the first half of the year, it's mostly less than 24 hours, and in the second half of the year, it's greater than 24 hours, approximately. And this time you see the duration varies significantly. For example, here, it's less than 24 hours by 104 seconds. So it's gone closer to 2 minutes. And on the peak, is 75.5 seconds greater than 24 hours, and slightly more than 1 minute. So it is fluctuating around 24 hours. And that is the important point. Even in the case of Boston, the average for the entire year continues to be 24 hours. That's what I'm showing here. This is a computed average. So once again, let me show these to you side by side so you get a clear picture. This is the Bangalore graph where the fluctuation is less than a minute, and this is the Boston graph where the fluctuation is closer to 2 minutes. On this side, it's close to 2 minutes. But in both cases, the average across 365 days of the year is exactly 24 hours. And that is the important point. And it is this average which the modern timekeeping has latched on to, and they have put a hard stop on the duration of a solar day at 24 hours. Every 24 hours, the clock just trips to the next day. Every watch, every clock is programmed like this, 24 hours, switch to the next day, hard-coded. But we cannot do that in the Hindu calendar, because in the Hindu calendar it is sunrise to sunrise. And that introduces a discontinuity in the design of a Hindu clock. But that is a topic for the next episode. So I will stop the video here. In summary, Bangalore or Boston, irrespective of the latitude, the average is 24 hours, but the variation of the duration of a savana or ahoratra is significant depending on your latitude. Bangalore is closer to the equator, Boston is way out of the tropics, and hence the variation of the duration is significantly different, but the average is 24 hours. And the Western clock, the modern timekeeping, uses this average as a fundamental design parameter in every clock. Whereas if I design a Hindu clock, and I have already shown it to you, Gati, Vikati and Prana, in that nadi, vinadi and prana, in that clock, if I continue to savana or ahoratra and deciding when to switch to the next day, there will be a discontinuity, and that I will explain in the final episode of the Ahargana series. So once again, I will stop this tutorial here. Thank you very much for watching.